Hello everyone, welcome back. Here we have a motion problem and it reads, a car is moving at a constant velocity of 51 meters per second for 40 seconds, accelerates uniformly at 4.5 meters per second squared for 10 seconds, after which it decelerates uniformly at 2.75 meters per second squared for 12 seconds. The brakes are applied and the car decelerates uniformly to rest in 18 seconds. Question A reads, draw a velocity time graph to illustrate the motion. Question B reads, calculate the total distance traveled. Question C reads, calculate the retardation of the car as it comes to rest. Question D reads, calculate the distance traveled 58 seconds in the journey. Question E reads, calculate the average speed traveled. So we have a velocity time graph question, and that's the first question we have. So how do we try to draw the velocity time graph? So having a quick analysis, we have a constant velocity. The body started moving with a constant velocity, then it accelerated, then it decelerated, then it decelerated again to rest. So that gives a general idea of how the velocity time graph is supposed to look like. Okay, so let's move on. So we will have velocity against time. Okay, velocity in meters per seconds and time in seconds. So the body was moving at a constant velocity. This is how you draw a constant velocity of 51 meters per second, and the duration was 40 seconds. Okay, so after what happened, the body accelerated at a velocity of 4.5 meters per second squared for 10 seconds. So if you should add it to the 40 seconds already traveled, you have 50 seconds here. Okay, after the acceleration, the body decelerated. Okay, it decelerated at 2.75 meters per second squared. Okay, for a period of 12 seconds. Now I know the question that you are wondering, which is, to what extent do you have to show the deceleration from this point onwards? And the only way you can be able to know is after calculating the final velocity, okay, of the third event. That will give you a general idea. But to give a quick explanation is, if I should try and sketch this 51, stretch it, meters per second, if you have a final velocity that is lower than 51 meters per second here, if you have a final velocity that is lower than 51 meters per second, it means that the line that you should draw from here downward should go way below the 51 meters per second. Let's say somewhere here. Okay, if you should have a final velocity that is exactly 51 meters per second, it means you'll have it somewhere here. Okay, but if you have a final velocity that is greater than 51, let's say somewhere around here, then it means you should draw as appropriate. Okay, but in the first instance that cannot be clear. Like I said, it can only be clear if you find the final velocity. Okay, so for now we will just go on with the assumption that we have a final velocity that is greater than 51. So let's say somewhere here. Okay, so after doing our calculation, if at all we were not right, then we can go on do the appropriate correction. But for now I am assuming that I'm going to have a final velocity that is greater than 51. And so what was the deceleration? It was 2.75 meters per second, and the time was 12 seconds. So if I should add it to the 50, I will have 62 seconds. Okay, then after that, what happened? The body decelerated to rest in 18 seconds. Okay, so if I should add that to the 62, I will have 80 seconds. Okay, so let me now delete the red line. Okay, delete the red line. Okay, okay, this is roughly how our velocity time graph is supposed to look like. The body start moving at 51 meters per second for 40 seconds, then it accelerated at 4.5 meters per second squared for a duration of 10 seconds, after which the body decelerated at 2.75 meters per second squared for a period of 12 seconds. Then it finally decelerate or retardates to rest in 18 seconds. Okay, so if you look at it, it means this motion took place in 4 different events. We have one here, the first event. This area is the second event. This area is the third event, and this area is the fourth event. So looking at the graph, it means that we have to find the final velocities at the end of the second event. We have something here. Okay, this point we should know it, so let's call it V2. And here we have this point is also a final velocity, and it is the final velocity of the third event. So let's try to find that also. So let me call it for now V3. Okay, so do not confuse which one is the final velocity of the second event or the third event. It's simple. Let me just try to make a quick revision. Okay, so this is the first event. Okay, this area is the area for the first event. So it starts moving from this point at 51 meters per second. So the initial velocity is 51 meters per second, and this point is the final velocity, which is also 51 meters per second. So for a body moving at a constant velocity, what happens? The initial velocity and the final velocity are the same. The acceleration is 0. Okay, but this area is for the second event, right? Here is the initial velocity, this point is the initial velocity, and this point is the final velocity. So what is the initial velocity for the second event? Is 51 meters per second. The final velocity for the second event is V2. We will find that. This area is the area for the third event, so it's a deceleration event. Okay, so the initial velocity will be here, the final velocity will be here. This area is the area for the fourth event, okay, it is a deceleration that brought the car to rest. So the initial velocity is here, which is going to be v3, okay. The final velocity is what? Is 0, because when a body comes to rest, the final velocity is 0, okay. So in summary, the final velocity of the previous event will serve as the initial velocity of the successive event, okay. So the final velocity for the first event will be the initial velocity for the second event, okay. So the final velocity for the second event will be the initial velocity for the third event. The final velocity for the third event will be the initial velocity for the fourth event. That's just the summary. And if it is going to confuse you, always consider your velocity time graph, okay. All right, so what do I need to do next? Let me try to find the velocities so that we can be able to complete our velocity time graph, okay. So for the second event, we know that if you have v is equals to u plus at, then I can say v2 is equals to u2 plus a2 t2. The final velocity for the second event is equal to the initial velocity for the second event plus the acceleration in the second event multiplied by the time taken in the second event, okay. So what is the initial velocity for the second event? This area is the second event, so it was an event of acceleration. The initial velocity will be here, the final velocity will be here. So what is the initial velocity? The initial velocity will be 51 meters per second, okay. So we'll have 51 plus what is the acceleration is 4.5 multiplied by what is the duration of the second event is 10 seconds. 10 seconds. So if you should calculate that, you will have 96 meters per second, okay. So I can just go and substitute that on the velocity time graph. Substituting that on the velocity time graph, v2 is 96 meters per second, okay. Now again, using v is equals to u plus at, so v3 is equals to u3 plus a3 t3, okay. So I'm trying to find the final velocity of the third event. So what is the initial velocity of the third event? Let's refer ourselves back to the velocity time graph. This area is the third event, okay. So what is the initial velocity? The initial velocity is this point, and that is 96. So the initial velocity is 96 meters per second, okay. So we'll have 96 plus what was the acceleration? The third event is a deceleration. The third event is a deceleration, so acceleration will be negative. So because deceleration is a negative acceleration, it reduces the speed of a moving object. So we're going to make the acceleration negative there. So we have negative 2.75, okay. And what was the duration for the deceleration? It was 12 seconds. So what will that give us? We'll have 63 meters per second, okay. I got that one also, so I can also replace that, okay. So the v3 is 63 meters per second, okay. Looking at the velocity time graph, that is it. Everything complete? Yes. So we can indicate the 0 here. Some examiners, do take note of that. Okay, that is the origin. It's important. Do not omit it. Okay, or do not forget it. Okay, so we are done with question A. So question B asks us to find the total distance traveled. Okay, so because the motion took place in 4 events, so I can call this area S1, this area S2, this area S3, this area S4, and the sum total of the individual figures will give me the total distance. All right, that's how you find the distance. So B, total distance traveled. The first event, I have S1, this is 40, and we have 51 here. So because it looks like a rectangle, the area of a rectangle is length times the height, so that will be 40 times 51. And what do we expect to get? 40 multiplied by 51, that's 2040 meters. Okay, moving on, we can continue and look at the shape of S2. It looks like a trapezium. Okay, so we have S2 like this. This is 51, this is 10, this is 96. Going back to it quickly. Yes, we are right. 51, 96, 10. Okay, so S2 looks like a trapezium. The area of a triangle is half A plus BH, where this will be A, this will be B, and this will be H. Okay, A and B are the two parallel sides. A can be the shorter length, B can be the longer length, if you like. Okay, so this will be half what is A, 51, plus what is B, 96, multiplied by the height, which is 10. So what do we have? Half 51, 96 multiplied by 10. We have 735 meters. That is S2. Okay, let's go and continue and analyze S3. We have 96 and 63 and 12. Okay, S3, the shapes looks like this. The shape, we have 96, we have 63, and then we have 12. That's S3. The shape, let me make a quick review. 96, 63, and 12. 96, 63, and 12. Because it looks like a trapezium also, H3 is equals to half A plus BH. So I can say this A, this is B, and this is H. That will be half. A is 63, B is 96, and the H is 12. What do I get? Half 63 plus 96 multiplied by 12. I have 954 meters. Okay, 954 meters. And finally, we have S4. It looks like a triangle. This is 18 and 63. Okay, 63. Okay, the area of a triangle is half base height. That will be half, the base is 18, height is 63. We have half, the base is 18, the height is 63, 567 meters, 67 meters. Okay, so we said that the total distance will be S1 plus S2 plus S3 plus S4. S1 is 2040 plus S2 is 735 plus S3 is 954 plus S4 is 567. Okay, so if you should calculate that, 2040 plus 735 plus 954 plus 567, we have 4296 meters. Okay, we can continue. Question C asks us to calculate the retardation of the car as it comes to rest. So to identify the retardation that brought the car to rest is this, from here to this point. Okay, that's the retardation that brought the car to rest. So the initial velocity will be 63, and because it comes to rest to this point, which means the final velocity will be 0. When a body comes to rest, its final velocity is 0 meters per second. Okay, knowing that information is important for the calculation. Okay. See, we know that if we have v is equals to u plus at, so acceleration will be v minus u divided by t. So the deceleration that brought the car to rest was in the fourth event, so I can just say a4 is equals to v4 minus u4 divided by t4, the 4 indicating that it's in the fourth event. Okay, so what was the final velocity the body comes to rest? It will be 0. The initial velocity was 63 and time is 18. Okay, so the initial velocity, let's go and review that quickly. That is here. Okay, it starts to decelerate to rest from this point, then it comes to rest here. So what was the initial velocity? 63 meters per second. Okay, so what do you get? You have 3.5. okay, negative 3.5 meters per second squared. Okay, know that deceleration is a negative acceleration. All right, so the next question, question D, asks us to calculate the distance traveled 58 seconds in the journey. Okay, so we will ask ourselves, where will we have the 58 seconds? Okay, the 58 seconds will be somewhere between 50 and 62. So let me just assume that is this point, okay, here. So if I should stretch a line coming way up to this point, you will realize that it was at the deceleration phase, okay? So, but it means that the velocity it will correspond with will be, if you should stretch that, it will be higher than 63 meters per second, okay, on the velocity axis, but is less than 96 meters per second. So I need to know that velocity, that final velocity, in order to be able to calculate the distance, okay? So it is very important. So I can call it Vx, okay? We can call it Vx because we need to calculate that. Okay, so because I said this point is 58 seconds, I need to ask myself from 50 here, how many seconds do I need to add to make it 58? And we will all agree that is 8 seconds. Is 8 seconds, right? Okay. That is from here to this point is 8 seconds. So, okay. Let me move on to calculate Vx first. So V, if I use V is equal to U plus AT, so Vx is equals to U, because it is in the third event, so I'll say U3 plus A3 TX, okay? Now, because we are talking about 58 seconds, and if you should analyze the velocity time graph, the 58 seconds here was in the third event. The body was in deceleration, so its initial velocity is here, that doesn't change. So it's the final velocity that we need to know, Vx, okay? And yeah, sorry, this 8 seconds here, that was a misplacement. It was supposed to be here, okay? 8 seconds was supposed to be here, okay? It is when you if you add it to 50, you'll have 58 seconds. Okay, glad that I have found that earlier. Okay, so what is the initial velocity? The initial velocity was, a quick review, it was 96. Okay, the initial velocity was 96 plus the acceleration was a deceleration, it was 2.75, that never changed, okay? And the time there was just 8 seconds. So how much do I have? .74 meters per second. So I was able to have 74 meters per second. So it means at 58 seconds in the journey, the car was traveling at a velocity, the final velocity there was 74 meters per second, 74 meters per second, okay? 74 meters per second. So I need to use that information to be able to know the distance. Let me call that the distance traveled as Sx, okay, which is just this distance here, So if I should add that to S2 and S1, that will give me the total distance traveled after 58 seconds in the event. Okay, so it looks like a trapezium, right? It looks like a trapezium. Okay, all right. So let's go on to draw that. Okay, and this is how it looks like. We'll have 96 here, we have 74, we'll have 8. Okay, and that is SX. All right, so SX, because it is a trapezium, the area of a trapezium is half A plus BH. That will be half, this will be A, this will be B, this will be H. So that will be 74 plus 96, and then the height is 8. What does that give me? That is 680 meters. So to be able to find the distance traveled after 58 seconds in the journey, that will be S1 plus S2 plus SX. S1 is 2040, S2 is 735, and SX is 680. Okay, how much is that? 2040 plus 735 plus 680. That is 3455 meters. Okay, so that is the answer for question D. Okay, so we'll move on to calculate the average speed, which is question E. Okay, calculate the average speed, and that's the final question. All right, average speed is equals to total distance traveled divided by the total time taken. So what is the total distance traveled in the journey? Was 4296 meters. Okay, 4296, and what is the total time? Is 80 seconds. 4296 divided by 80, that gives 53.7 meters per second. That was the average speed. Thank you for your patience. Okay.